This is one of the 4 tutorials I'm making up to support teachers when they have to write the math proficiency test. And we're going to focus this one on the linear and nonlinear relationships. So these 4 bullets here recognize the linear versus nonlinear relationships, solving them graphically, numerically, algebraically, and some equations, and then linear systems, solving them graphically too. This is an image of a YouTube video I made some time ago. Here's the link here. I'll put an end card here so you can have a link that you can click on. This talks about a lot of the characteristics of linear relationships, specifically ones that are written in y equals mx plus b, which is used a lot. So that might be worth, if you haven't seen that kind of material for a while. It's not terribly long. It's just about 15 minutes. So that's a resource that you can access. So let's take a look at some examples. And so in this first one, Jared arranges to have some work done in his furnace. He's told there's a $90 service fee call, and on top of that, he'll have to pay an hourly rate of $75 an hour. So the question is, which of the following represents the total cost C in dollars for n number of hours of work they spend fixing Jared's furnace? So, and here's the 4 options. Almost all of these examples I make up are multiple choice, because that's what they are on the math proficiency test. In a few of these tutorials, there's a few that aren't, but like 95% of them probably are. So first of all, we're told that relating this to y equals mx plus b, the rate of change is $75 per hour. When it says an hourly rate is $75 per hour, that's the rate of change. Rate of change tells you the rate at which something is changing. The fixed fee, or the initial fee, would be the $90 one-time fee that you pay. When you have somebody come to your house, doesn't matter whether they work an hour or 8 or 9 or 10 hours, if there's a service call fee, you pay that once. It's the hourly fee, you pay some per hour. So the 75, so relating it to y equals mx plus b, m is the rate, and the b is the initial amount, or the fixed amount. So we put the 75 where the m is, and the 90 where the b is. And of course, instead of y, we're calling it cost C. Instead of x, we're calling it the number of hours. And so C equals 75n plus 90 would be the correct answer for this one. Example number 2, Avery buys a bus pass, and we're given this table. The amount remaining on the bus pass is shown for a few number of uses. So for 3 uses, we're told that she has $117.50 left. For 6 uses, there's $110 left. And we're told that the relationship between the value remaining and the number of times used is linear. So we're asked to complete the chart with the missing values, so to find these 3 values. So if you look at the difference between $117.50 down to $110, it's gone down $7.50, and that's for a change of 3 hours, from 3 hours to 6 hours. So we're going to find the rate of change and use that to find these 3 missing values. So the rate of change would be the change in value from here to here, which is the 750, it's gone down, over the number of times it's used. So from this one to this one, it's been used 3 times. So we would divide that by 3. And so 750 divided by 3 works out to $2.50 that she's used. And just to show you a little bit about the remember, this is the calculator you get to use for the math proficiency test. So if we take, and I'm not going to worry about typing in the negative, so 750 divided by 3 is 2.5, or $2.50. So how we can use that is from here to here, it must have gone down $2.50. So $117.50 minus $2.50, that would have to be $115. And then to get the next one, we're going down another $2.50. So from $115, if you subtract $2.50 from it, this would be $112.50. And then to get the last one, it's $250 off of the $110 that was left after 6 uses. So that would be $107.50. So that's how we find, or how you can find, those 3 missing values. So this is one of the questions that wasn't a multiple choice. This is multiple choice. Example 3, at a bowling alley, they offer 2 different payment plans for monthly shoe rental. Which statement is true? So this is one of the questions where we're going to solve this system graphically. There's 2 lines, and this point where they intersect right here is an important point. This is the number of shoe rentals, and this is the cost. So at that point right there, we can see at 7 shoe rentals, the cost is the same for the 2 of them. And that's quite important for a couple of these options here. So A says option B is always cheaper. Well, option B isn't always cheaper. Option A is cheaper here. See, option B is a fixed $25 forever. It doesn't matter if you go and rent shoe rental, well, if you miss the whole month, or if you rent them like 30 times, it's $25 no matter what. So option B is only cheaper after 7 rentals. Here, see, option A is higher in this region of the graph here. So A is not correct. If you rent 4 times, if you bowl 4 times in a month, it says option B is $11 cheaper than option A. Well, for 4 rentals, option A cost, see, that would be $15, so it's about $14. It's just under the $15. And option B's cost is always $25. Now, the difference between them is $11, but option A is the cheaper one, not option B. See, this says the opposite. It says option B is $11 cheaper than A. So the opposite is actually true. If you bowl 4 times in a month, it's option A that is about $11 cheaper than option B, not the other way around. So B is not correct. C says option B is a better deal if you bowl more than 7 times a month. So here, this is the point that I was talking about. At 7 times a month, they both cost $25. Option B is a better deal if you bowl more than 7 times. Well, that's true, because you see, once you go to 8 or 9 or 10 times, option A is more expensive. So if you bowl 7 times in a month, the cost is the same. Below 7 rentals, option A is the cheaper one. But after 7 rentals, option B is cheaper, so C is the correct one. And just to I'm not going to just stop there and not worry about D here. D says option A is a better deal if you bowl less than 10 times in a month. Well, if you bowl 10 times, they aren't the same at 10 times. It's actually 7 times. So option A is a better deal if you bowl less than 7 times in a month, not 10. Example number 4, and this is one of the ones where you're comparing different representations of linear or nonlinear relations. So we're asked, which one is a nonlinear relation? Well, this one's pretty simple because it's a straight line. Linear means it's a line. So because this is a line, it has to be a linear relation. Now, when you have tables like in B and C, what you have to do is compare the how the x's or y's or whatever the variables are going up or going down. So if you look here, see, this is going up by 1 each time, so that makes it more convenient to check here. And so notice that the y's from -4 to -1, it goes up 3. Think of temperature. If you're at -4 and it goes up to -1, you've gone up the thermometer 3 degrees. From -1 to +4, it's gone up 5. From 4 to 11, it's gone up 7. Now, if these are all going up by the same amount, 1, or it doesn't really matter what, but 1 makes it convenient, and these are changing by different amounts, that means this is nonlinear. These are called the first differences, and if they're different, it's nonlinear. If they're the same, it's linear. So the nonlinear one would be this B one. Now, just to look at C and D, C, now these aren't going up by 1, but they are going up by 5 each time. And so, again, as long as these are changing by the same amount, so from -2 to +5, that goes up 7. From 5 to 12, it goes up 7. From 12 to 19, it goes 7. And because these are see if these are the same number all the way along, and these are the same number all the way along, this is going to be linear. We could actually calculate the rate of change. It's now that little triangle stands for change in. The change in y over the change in x is the rate of change. You'll see that that'll come up a lot of times in a lot of these examples. And so the rate of change is this 7 over this 5. And because the rate of change would be the same here, see 7 over 5, 7 over 5, they're all the same, so this would be a linear relationship. Now this is written in y equals mx plus b form, okay, y equals mx plus b, so this would have to be a linear relationship. Example number 5, a box of crackers has different masses depending on how many crackers are in the box. Which of the following represents the relationship between the number of crackers n, so n is the number of crackers in the box, and the total mass of the box? So now the mass depends on how many crackers are in it, so that's why all these formulas are written as m equals something, m equals something. And here's the graphical image we have here. Now, notice that if we can draw a nice straight line through them. Okay, so this is linear, and there's a fixed value right here. See, that value right there, see, this would be 0 on the horizontal axis, the n axis, and at 0, the mass is 50. So, and this is mass up here. So that tells us that the fixed value is 50, so that must be the mass of the box when there's no crackers in it. So that's the fixed value. Now, what I'm going to do is I'm going to join two of these points together and draw, these are called rate triangles. And the change here and the change here will allow us to find the rate of change. Now, from here to here, see it's going from 20 to 40, so that's 20. And from here, see it's going from 100 to 150, so that's 50. You always have to pay attention to what the scale is in the axis. See, here every block is 10 because it goes 10, 20, 30, 40. So this is 2 blocks, so it has to have another reason I know it's 20. This is going up by 50, 50, 100, 150, 200. So the vertical change is 50. Now, the rate of change is the change in the mass being what's going up and down here, which is the 50, over the change in the number of crackers, that's 20. So we fill in 50 as the change in the mass for a change in the number of crackers of 20. 50 divided by 20 tells us that the rate of change is 2.5. That would actually be 2.5 grams per cracker. So that's actually the mass of a cracker. And the reason I know it's grams per cracker is because this is 50 grams, and this 20 is the number of crackers. So that's how I know the units are grams per cracker. So using y equals mx plus b, y equals mx plus b, the mass must be, and this is the rate of change times the number of crackers plus the 50 constant value on the end. So that means that C, it would be the correct equation. Example number 6, which is an equation for this line shown? So we're given 4 different equations here for this. And so the first thing that we're going to do is I'm going to plot a couple of points here. And you pick places that you're very certain you know the exact coordinates of the point. So for example, this point here wouldn't be a very good point to use, or this point here, because it's very difficult to identify exactly what the x and y coordinates are. You know, okay, so the scale is 1 here. That looks like it, you know, maybe it's like 0.7 or something like that, but you're estimating. Okay, so that's not a good point. This point here, if you look at it, we're very certain that that's the point 0, 6. This point here, the line goes through that point exactly, so that's the 0.32. Okay, from the origin you go over 3 and up 2, so that's the 0.32. So those points are, we're going to use those to find the rate of change. This point here also, that's the y-intercept, the b value when you write y equals mx plus b. So that's the number on the end of the equation. Actually, so if you look over here right now, there's only 2 equations that have a 6 on the end. So that kind of rules out b and d here. But let's continue with finding them. So finding the equation. So this value here is the rise, and it's how much it goes up or down. So that goes down 4 from 6 to 2. This number, this amount across here is called the run, and it's positive 3. So the rate of change is the change in, this is the y-axis, over the change in the what's on the x-axis. And the change in y is the negative 4. And the change in x from this point to this point is 3. So we see it's going down 4 and to the right 3. So that's the rate of change. And so if you look at the 2 equations that have that plus 6 in the end, see, C is the one that has the negative 4/3 for the equation, for the rate of change. So if we relate this to y equals mx plus b, see this is the m and the b is 6. So we put negative 4/3 x plus the 6. So that's why C is the correct answer for example number 6. And example number 7, Sylvester picks strawberries as a summer job. He's paid a base salary plus a certain amount for each basket of berries that he picks. The table below shows his earnings for 5, 10, 50, 20, and 25 baskets picked. That's what's shown in the table. If Sylvester works a really long day and manages to pick 73 baskets, which of the following is closest to his earnings for the day? So we're given 4 answers here. This is another multiple choice. So the first thing I'm going to do is calculate the rate of change. The rate of change would be his change in the earnings divided by the number of the change in the number of baskets you picked. And if you look, for example, from here to here, this has gone up 5 baskets. And notice from $27.50 to $35, he's increased by $7.50. So we fill in $7.50 for the change in the earnings and 5 the change in the number of baskets he picked. And if you divide that, he's making $2.50 per basket of strawberries he picks. Now, if we relate this to y equals mx plus b, see the 250 is the rate of change. That's what's going right here. So we would put the earnings, and it's earnings, not y, equals 2.5 times n. Now, the b value, that's the initial value or the fixed value. And if in the table, if you have the value for 0 in this column, then the fixed value is what's over here. So look, if you go back 5, then this would be 0. And so if we go back, like back 750, like 750 less up here, 750 less than 2750 would be $20. So $20 is the fixed amount because that's what he's paid even if he doesn't pick any baskets. So he has some kind of a fixed part of his income. So 20 is what goes on the end here. So that's the equation. Now, the question asks if he picks 73 baskets, what's he going to make? So in the equation, we're going to put 73 in place of the number of baskets. So we'll do the calculation over here. So 2.5 times 73 plus 20. So if I bring the calculator over here again, whoops, didn't mean to do that. And there we go. So I want to clear this. So we go 2.5 times 73 equals, and then we add the $20. So 202.50. We'll get rid of this. That's what he would earn if he picked 73 baskets in a day. So 202.50 here is the correct answer for number 7. On to number 8. So it says which relationship is most likely to be represented by this graph. So we have a scatter plot here. It does look pretty linear. If you draw a line of best fit, probably looks something like that. That touches most of the points with one below and one above. And when you draw a line of best fit, you don't want to have like a whole bunch on one side that aren't on the line and only like one or two on the other side. So that's a pretty accurate line of best fit. And we're given all these scenarios: the volume of juice in the jug versus its mass, the amount of water in the pool versus the time the pool has been draining, the amount of propane in the tank versus the number of times it's been used for a barbecue, and the amount of money in your bank account versus the number of days after you've been paid. So which of these could this graph be representing? Now, this graph is trending upwards, which means as the x variable increases, so does the y. That's called a positive. These variables are said to be positively correlated. So that's what the line of best fit looks like. And when it trends upward, the variables again are positively correlated. So what that means is that when one variable increases, so does the other variable. And if one variable decreases, then the other one does as well. So let's talk about these scenarios. Volume of a juice in the jug versus its mass. So that would have to be, those variables should be positively correlated, since as the volume of the juice goes down, so would the mass of the jug, or if you put more volume in the jug, it's going to have more mass. So A should be the correct answer here. Okay. Let's talk about the other ones, just so you can see why those aren't the correct answers. The amount of water in the pool versus the time it's been draining. So these variables would be negatively correlated, since as time increases, the amount of water in the pool decreases. So they would be negatively correlated. Okay, as one variable goes up, the other one goes down. So that couldn't be what's happening here. The amount of propane in the tank versus the number of times the barbecue is used. Again, these variables should be negatively correlated, since as the number of times the barbecue is used increases, the amount of propane in the tank should go down. The more you use it, the less propane should be in it. And the last one, the amount of money in your bank account versus the number of days since you've been paid. These variables should be negatively correlated, since as the days pass by or the number of days increase, you spend money, so there should be less in your bank account. Okay, so they would be negatively correlated as well. So the only correct one here would be A. Example number 9. Mortimer chooses a cell phone plan that charges a flat monthly fee of $25 plus 15 cents per text message. So you're asked, which of the following equations relates the cost, C, in dollars to the number of text messages, M, that are sent? So C is the cost in dollars, and M is the number of text messages that she sends. So the $25 flat monthly fee is the fixed or the initial amount. So it's the constant. It's not multiplied by any kind of a variable in the equation. The 15 cents per text is the rate of change, because every time she sends a text message, she's charged that. So it's like cost per hour. Okay, if you're working, you're making like $28 an hour, then that's your rate of change. Here, the rate of change is the cost per text message. That's the 15 cents. So that's what's multiplied by M, the number of texts sent. So we relate this to y equals mx plus b. So the fixed amount or initial amount, that's 25, and the rate of change should be this. So if we rewrite this, okay, so this is C and this is N, okay. So C would equal 0.15 times the number of text messages plus the fixed amount. And if you look at, so that's the correct answer, A here. If I calculated the cost for 10, I did 10, 74, and 24. So if you want to know the cost for 10 text messages, you would go 10 times the 15 cents plus 25. That's $26.50. If you want to know the cost if she sent 74 text messages in a month, you would go 74 times 15 cents plus 25. And if she instead sent 124, you go 124 times 15 cents plus 25. So notice this has the same format as that equation. Okay, 0.15 times the number of text messages plus 25. And on this last page, I'm going to take a look at a couple of examples similar to the equation part of the math proficiency test. And so the first one here says solve, and some of them are just straight solve. This one here is a bit of a different twist on it, because instead it's saying that which of these has 8 as the solution. So I'll show you how to handle those as well. So solve 55 equals 5 times m plus 2. So the first thing that we're going to do is, I'll copy my equation down, and I'm going to, so the 5 and the 55 are both divide evenly by 5. So I'll divide both sides by 5. So 5 goes into 5 once. Now you can put a 1 here if you want, or often if there's a 1, you don't bother. 5 goes into 55 11 times. So there's going to be 11 left on the left side here. So the equation now is 11 equals, and we can drop the brackets, 11 just equals m plus 2, and I'm trying to solve for m. You can solve this by inspection. You know, what number do you add 2 to get 11? Okay, so you could, but algebraically, this is what we would do. To isolate the m, I have 2 added to it right now, so we do the opposite of adding 2. So the opposite of adding 2 is subtract 2. So I'm going to take 2 away from the right side. Whatever you do to one side, you have to do to the left. So I'm subtracting 2 from both sides. So this part here is gone, leaving m isolated or alone on the right. And 11 minus 2 is 9. So m equals 9. So 9 is the correct answer here. And again, by inspection, it's 9 that you add 2 to give you 11. Now, you could instead, with these equations, there's only 4 answers. You could check which one works. So for example, if I put 9 in here, if I go 9 plus 2, okay, see that's 11 in the brackets, times the 5, see that does give me 55. If I check negative 18, for example, if I put negative 18 here, so 18, and we make it negative, so you add 2 to it, so plus 2 equal. Now make sure you hit equals before you multiply by the 5. Times the 5, see it doesn't give me 55, it gives me negative 80. And for example, you know, if I wanted to check the 10.6, I'm putting 10.6 here, so go 10.6 plus the 2 equals times the 5, okay, equals 63, not 55. Okay. Now, I showed you how to do the 9. A little bit about the calculator here. If I just, okay, I'm putting 9 right there. If I go 9 plus 2, and then just go times 5, okay, oh, actually, that does work that way, right? You have to be careful with this calculator, because it doesn't, you have to do the order of operations for it, and actually, I guess when I do this, I am. So 9 plus 2, before I hit anything else, it's actually automatically doing the equals, because there's the 11 times the 5 gives you the 55. So just be careful when you're using the calculator that you're using it correctly. Okay, example 11, x over 3 plus 5 equals 12. So I'm going to rewrite the equation over here. And the first thing I'm going to do is get the x over 3 alone. So the 5 is added to it. So the opposite of adding 5 is to subtract 5. So I subtract 5 from both sides, and see this is going to be gone, because plus 5 minus 5 is 0. So we're left with just x over 3 on the left, and 12 minus 5 is 7. Now I'm trying to find what x is. This really equation says what number divided by 3 is 7. Okay, and if you can solve that by inspection, okay, you'll know that it is 21, because 21 divided by 3 is 7. If you know your multiplication tables, then that works. But algebraically, what we would do is this. To get the x isolated is, right now it's divided by 3. So the opposite of dividing by 3 is to multiply by 3. So I do that both sides. And these 3's divide out, so leaving me with just x on the left, and it would equal 21, because again, 7 times 3 is 21. So 21 is the correct answer here. And again, you could check other answers, like, is there another possible answer here? So, for example, 7. Does 7 work? Well, if I do 7 divided by 3, okay, and then add 5 to it, I don't get the 12. I get 7.3, okay? So 51, for example, if I do 51 divided by 3 here, and then add 5, I get 22. I don't get 12. Okay, so those answers don't check. So the last one here, example number 12, says which equation has x equals 8 as a solution? So here we're checking. So what I would do in this equation, on the left side is the only place there's an x. So I'm going to put 8 where x is. So 3 times 8, and then take away the 18. And if it evaluates to give me 4, then 8 is the solution for this one. So 3 times 8 is 24. Subtract 18. 24 minus 18 is 6. It's not 4. Okay, so it doesn't, that 8 isn't the answer because it doesn't check in the equation. Just make both sides have the same value. So A isn't right. So C here, so I'm going to put 8 where the x is. So 8 here. 8 plus 5 is 13, so this is 4 times 13. And if you multiply 4 by 13, you get 52. You don't get the 50 that's on the other side. So 8 doesn't check in this one, doesn't make both sides have the same value. For C here, so I'm going to put 8 in place of x, and because the 5/2 is a fraction, I'm going to write 8 as 8 over 1. And you see, we multiply the numerators and the denominators, so this would be 40, 5 times 8 is 40, divided by 2 is 20. And subtract the 7, and see that does equal 13. So that's why this one checks. So that is the correct answer. Now, just to show you that 8 doesn't work in this D one here, I'm going to put 8 right here in place of x, and I'm going to use 8 over 1 because I have this quarter here. See, 1 times 8 is 8 on the top. 4 times 1 is 4 on the bottom, so 8 divided by 4 would be 2. So the left side value is 2. Well, what happens on the right side? So again, I'm going to put the 8 where the x is, or 8 over 1. See, 1 times 8 is 8. 2 times 1 is 2 on the bottom, so 8 divided by 2 is 4. So this is 4. Subtract the 6. See, that works out to be -2, not +2. So the two sides don't have the same value, so that doesn't check. Now, if you want a little bit more instruction about solving equations, I'll put an end card up here that you can click on to get to this video. There's the URL. I didn't mean to do that. It is 11 minutes and 8 seconds long, so it's not too long, so another 11 minutes. But there's a whole bunch of examples showing you how to solve linear equations within various operations, like I did for 10 and number 11 here. And that is the end of the tutorial.